Park Industries web video, tool oscillation in Alphacam. In this course, we'll learn about tool height versus material height, how to set up oscillation, and how to add it into a style. In this scenario, we just bought a new flat polish wheel to replace the position 5 polisher in our T30 profile set. The new polisher that we bought for oscillating is 60 millimeter diameter by 50 millimeter height. Our material thickness is 3 cm. So the polisher, 60 millimeters by 50, equates to about 2 3/8 diameter and almost 2 inches tall. The first thing we have to do is we have to add this tool into our tool library, which I have already done. I found a position in number 6. I've applied all the manufacturer's specification, the feed rate, and the spindle speed. Next, I need a shape to cut, which I've drawn, a 36-inch square. And I'm going to select my polisher as my active tool, and then I'm going to go to cut shape and go through and set up all the proper parameters for this particular cut and apply the cut as normal. Now I can add oscillation to the cut. To do so, I'm going to display my operations. I'm going to right click on that operation and I'm going to choose oscillation. The oscillation window comes up. The first thing I'll do is check the box to apply oscillation. Now I have to fill out the rest of the parameters. To better explain the oscillation parameters, I've drawn a rectangle to represent 3 cm material. I've also drawn another rectangle to represent our 60 by 50 millimeter polishing wheel. As with most flat end tools, I choose to run them slightly below the bottom of the material, in this case 0.1. I've offset this purple line to represent that. I've also offset another purple line from the top down to represent another cushion, so to speak. This allows me to measure from the top of the material to that cushion, and it gives me a value that I can set in oscillation. I can use that value for the height in my oscillation page. Another reason why I'll use this picture is to show for Z position that my tool can only travel down. Therefore, for Z position, I'll make sure that I set below as one of my settings. The type of oscillation that we usually choose is zigzag. Zigzag creates shorter programs and just as effective. The last thing is the pitch. What the pitch represents is how many linear inches along the edge of my part to make a full up and down movement, which will go back to our part to see the effects of it. It's easier to see the oscillation if we go to an isometric view. So here's our part, and here we see our 2-inch pitch. What that means basically is between peak to peak, if we are to go measure, we will find out that it is what we set for pitch, 2 inches. If I want a longer, more gradual movement, I'll simply come in and change the pitch to a larger number. I'm going to change it to 6, so it'll be 3 times the length. Now this operation contains oscillation. I can convert this operation, just like any other, into a style by either saving it as a new one or adding to an existing style. In this case, as I mentioned in the beginning of the video, I'm going to add this into our T30 style. I'm going to select my T30 and click on open. At this point now, in my style, in my T30 style, I should have a new operation at the end of it. This obviously isn't where I want my polish to run, so I'll highlight it and arrow it into place. I'm going to use that flat polish instead of my position 5 polisher, so I'll highlight that one and delete it. So my tools now are a Z-wheel, position 1 through 4, my polisher, and then 6 and 7. Now to get a visual to see what we've done, I'm going to take and I'm going to delete off this tool path, and I'm going to use this style and apply it as I normally would. And here we can see from here on out I have one tool within the style that oscillates.